Welcome back, guys. All right, so example 6, we're talking about formula 2, which is this guy over here. Okay, so I'm going to show you how this one works and then show you a few examples of how this guy works, okay? All right, so f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So I'm just going to show you where this guy comes. I'm going to show you in Desmos for this guy again. Okay, so what we're doing here sorry, I just want to modify something here. Oh, what did I do? Okay. So like we did in our last case over here, so now we have a cubic function. This is f of x equals 1/2 x cubed plus 3. So this is the red graph's the cubic function. And I want to figure out the slope of the tangent at this point over here. Okay, now this point is 2, 7. I'm just going to label this one as x, f of x. Okay. Now what I'm going to do over here is the way I'm defining this point is I'm going to take x and I'm going to add a value of h. Okay, so you can see over here, this is now 2 plus h, comma, and then my y is going to be f of 2 plus h as well. So if I add h plus to my x value, that means it's going to become f of x plus h over here. Okay, so in this case, h is like a positive 1.5. So my x is like, I've increased x by 1.5. And that means in this case, my y value is going to be bigger as well. If h is a negative value, I mean, my point is just going to the left now. Okay, so it's still x plus h, but h is now negative 2.2 over here. Okay. Now, what I'm doing now is I want to calculate the slope between these 2 points. Now, it's going to, again, slope calculation is y minus y here, this one, and then x minus x, x plus h over x. So what you can see over here is like the way this cancels out is it goes 2 plus h minus 2. Okay, so that's why the 2 minus 2 is going to cancel out in this case. I'm going to put just an h over here. But the way that this green point has to approach this blue point is my value of h has to approach 0, right? So if h gets closer and closer and closer to 0, okay, that means this green point is approaching this blue point over here. Okay, so it's going to be approaching it. And that means my secant line, which is a secant line over here, is approaching the slope of my tangent line over here. Okay, so this is kind of how formula 2 works for this one. So again, it's a limit as h approaches 0 of f of x plus h minus f of x. It's y minus y. This is just a slope calculation. Now the reason why it's just h in the bottom is because my x was x plus h minus x, and then the x plus h minus x just canceled out. Okay, so that's how this guy canceled out, like this. So I'm just going to write this out one more time here. If we have a graph like this, and I have this point, which is x, f of x, and this point now, I'm going to define it as x plus h, comma f of x plus h. Okay, and I'm going to draw the secant line between them. Okay, so again, how this works is we want this point to approach this point over here. Okay, now my slope calculation is y minus y, f of x plus h, minus f at x. It's the same thing that we see over here, over x minus x plus h minus x. X minus x cancels out, and that's why we just have the h over here as well. And the reason why this limit is h approaches 0, how do I make this point approach this point? Well, if this guy starts to approach 0, that means this x plus h is going to approach this value of x over here. Okay, so this is how formula 2 works. So example 7 says, determine the derivative of y equals the square root of 2x plus 5 using formula 2. So this is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So it's going to get a little bit kind of a gnarlier calculation here. All right, so here's the first part. This is my f of x plus h. All I'm doing is replacing x with x plus h. So I get the square root of 2 times x plus h plus 5, and then minus f of x minus square root of 2x plus 5 over h. Okay, now, if you remember from the beginning of this series of lessons here, when we have radicals in the numerator like this, we want to multiply by the conjugate and rationalize the numerator. Okay, so what's that going to equal? We'll rationalize the numerator. Really what it's going to do is going to get rid of all the square roots of the numerator. So when we multiply, so this term times this term, the square roots just disappear. So it's 2x plus h plus 5. And then the two middle terms cancel out. And it's going to be minus this term minus this term, 2x plus 5, all over h times square root of 2x plus h plus 5 plus 2x plus 5 equals, I'm just going to clean up my numerator a bit, 2x plus 2h plus 5 minus 2x minus 5 all over h, square root of 2x plus h plus 5 plus root 2x plus 5. Okay, now the 2x cancels out with the 2x, the 5 cancels out with a negative 5 there. And so what I'm left with is the limit as h approaches 0 of 2h over and these h's cancel out. Okay, now again, this is what we're trying to get to using formula 2. We want the h's to cancel out so that now I can put my h equals 0 into this guy over here. Equals 2 over square root of 2x plus 0 plus 5 plus square root of 2x plus 5. So this is just going to be 2 over square root of 2x plus 5 plus the square root of 2x plus 5 equals, so this is f prime of x equals 2 over 2 times the square root of 2x plus 5. Now these 2's can cancel out. And that is our answer for this guy right here. F prime of x equals 1 over the square root of 2x plus 5. Okay. Calculate the derivative of g of x equals 4 over x minus 3 using formula 2. So formula 2 is f prime of x equals the limit as h approaches 0, f of x plus h minus f at x all over h. Okay, so the way this formula stands, I can't put h equals 0 in right now because it's a non-permissible value. I need to do something to the numerator so that I can cancel out an h in the top and the bottom. Okay. So for this time over here, where I have like a fraction minus a fraction, I want to get a common denominator for these guys. So what I need to do here is I'm going to multiply the top and the bottom of the first term times x minus 3. I'm going to multiply the top and the bottom of the second term times x plus h minus 3. Okay, so this is going to be equal 4x minus 12. I'm just going to multiply this through. Minus, now I can take this negative 4 through here as well. Minus 4x minus 4h plus 12 over x plus h sorry guys, my pen's not working properly. Okay, over x plus h minus 3 times x minus 3. Now, this h is really h over 1. I'm going to pull that into the denominator over here as well. Okay, so now a whole bunch of stuff cancels out. This 4x cancels with this 4x. This negative 12 cancels out with this 12 over here. And I get negative 4h over x plus h minus 3 over x minus 3 times h. And these h's cancel out. Okay. Now again, this is the goal for Formula 1. We want to get rid of this h, so now I can plug in an h in for everything else. Equals negative 4 equals negative 4 over x plus 0 minus 3 times x minus 3 equals negative 4 over x minus 3 squared. So f prime of x equals negative 4 over x minus 3 squared. And this is our answer for our derivative over here. Okay, so the graphs of functions and their derivatives and what they represent. All right, I'm going to go back and show us one of our examples over here. Let's do 5x cubed. Okay, now what Desmos is really kind of cool for as well, I can just do this. You know, y equals f prime of x over here. And it actually graphs me the derivative of this blue function over here. Now, what we calculated was f prime of x was equal to y equals 15x squared. So now you can see this green graph and the blue graph are the same thing over here. Okay, but what does this actually represent? Okay, so I'm just going to go f of x compared to f prime of x over here. So if I was to take a look at this point and say, let's look at the point 1, 5. Okay, this is a point that's on my original graph over here. Okay, now if I put in a 1 into this guy, and we know, guys, we know that this was 15x squared. Remember, if I put a 1 into this guy, that means 1 squared is 1 times 15 is 15. Okay, so on this graph, we have the point 1, 15. Okay, now what this gives us here, so what's this representing on the graph? What at this point on my original function, the slope of the line that's tangent to this curve is equal to 15. Okay, so if I want to go ahead and graph this guy, so how do I graph it? So the slope is 15, passing through this point, x minus 1. Okay, so this guy over here, this blue line is tangent to my cubic function at the point 1 comma 5. Okay, so the graph of a derivative, the x is the same x as the x value in your function, but on the function, this is the y value, but on the derivative, this is the slope of the tangent at that specific x value over here. Okay, so in other words, when x equals 1, the slope of the tangent of this blue line is going to be 15. Okay, and this is how this guy works. Okay, so this is kind of just talking about how graphs of derivatives work, guys. And in your textbook, guys, there's just some examples on this as well. All right, guys, so this is kind of the conclusion of what we call the formal definition of a derivative. I hope this makes sense. And guys, please do all the practice, guys. And when I say I hope this makes sense, guys, I know this is quite a conceptual, a very conceptually difficult idea over here. It takes practice, guys. You need to kind of use Formula 1, Formula 2, guys. You need to do at least like 10 questions for Formula 1, 10 questions for Formula 2 so you get really comfortable doing those. And please come and see me if you have any questions on any of these ones over here as well, guys, because this is definitely a very fundamental skill for the rest of this course over here. All right, guys, please send me a note if you have any questions about this as well. See you soon.